We experimented with 3 substances: sugared water, Gatorade, and orange juice. These substances are the independent variables, while the laser and the angle of refraction are the dependent variables. We poured the substances into a petri dish and then put it on top of a protractor. Then we used the laser, pointing it at an angle of incidence. This gave us the angle of refraction. Before we could make any more conclusions, we had to research. We found refraction means bending or breaking, and it occurs when light passes from one medium to another and it bends the light ray. Refraction is what makes up image formation in lenses and in the eye. The amount of bending depends on the indices of refraction of the two medias and is explained by Snell's law. The formula for Snell's law is n1 divided by n2, and it is proportional to sine 1 divided by sine 2. Our group used Snell's law to find the refraction of the laser it passes through a medium to another. The use of refraction can help invent better microscopes and telescopes, since those inventions deal with light refraction. Today, scientists most commonly use population-based studies to test refraction. They create experiments and receive data from hundreds of different people to have more precise numbers. The equation we used in our experiment was Snell's law, which was previously explained. Our group predicted that there was going to be a great difference for the index of refraction for the Gatorade, but the water with sugar and orange juice might be similar. We also thought that there would not be as much of a difference between air into substance and substance into air. Here were our independent and dependent variables. Independent variable. The independent variables were the substances: orange juice, Gatorade, and sugars with water. We changed the substances on each trial to determine how the laser reflects them. Dependent variable. The dependent variable is how the light refracts on each substance. As the laser goes through the substance, the light would bend. We want to see if each independent variable is different from each other, since they all are different substances. Our setup consisted of water, sugar, orange juice, Gatorade, a protractor, and a professional red laser pointer. We started our experiment with air into substance. We used water with sugar for our first substance to experiment. The first thing we had to do was fill half of the petri dish with water and pour 1 spoonful of sugar into the petri dish. Then we had to even out the sugar. We put the petri dish on top of the protractor. Then we used the laser and pointed it towards the dish, placing it on the line labeled A 10 degrees. We pressed the button on the laser pointer and aimed the laser beam at the intersection of 0 degrees and 90 degrees. We observed and recorded where the laser beam traveled from the air into the substance. That is the angle of refraction. When we recorded the angle, we made sure to label the substance it is from. We also used different colored pens for each substance to be more organized. Repeat steps 3 through 5, changing A 10 degrees to B 20 degrees, C 30 degrees, and so on until G 70 degrees. We got another petri dish, filled it up halfway with Gatorade, and repeated the steps we did with the previous substance, recording for the angle of refraction. We then repeated the same process using orange juice. For substance into air part of our experiment, we repeated the same steps as with air into substance, but we placed the petri dish the opposite direction on the paper. As we were doing the experiment, we took the data on the paper protractor. Each substance's angle of refraction was measured with a different color, and it was marked by a capital letter, according to the critical angle A through G. We used the data that we put in the protractor, which were the angles of refraction. With the angles of refraction, we could calculate the index of refraction, which we found by using Snell's law. This would be our data for a substance into air. To clearly see a comparison and contrast in our experiments, we created these graphs by graphing it in a calculator and finding the equation in the form of y equals mx plus b to be able to see the relationship between the angles of incidence and the angle of refraction. On the y-axis, we labeled it air into substance of the liquid, and on the x-axis, we labeled it whatever substance it was: water with sugar, Gatorade, and orange juice. Our data did not support our hypothesis. The 3 substances were close to each other for the angle of refraction. There was not a great difference between each other. We also predicted that there would be no difference between the refraction of air into substance and substance into air. We were also wrong on this because there was a difference, although it was not a great difference. Adding too much sugar or not evening out the sugar can create errors, pouring more or less than half of the petri dish. Another error that we could have done is not being organized, such as not using different colored pens for each substance, or marking the wrong angle can create an error. Also, if we don't use Snell's law correctly, like not using the correct angles can make an error in our experiment. If we could do this experiment over again, we would use more substances to see if there is a greater difference in the index of refraction. It would allow us to experiment with different properties of substances such as color and density and be able to see more and greater differences. Doing this experiment made our group realize that there is many aspects to an experiment. There is a lot of trial and error, and we have to make sure that those errors are minimal. Our group did stay within our budget. Everything was not too expensive. We did not need additional equipment. We had everything we needed for the experiment. On the other hand, we would have liked to add more substances to see if there would have been a difference in our data. Science is study that can change through many different trials.